Section 7.5, Matrices and Matrix Operations. So we're learning about matrices. What are matrices? Well, they're these big boxes with lots of numbers in them. Matrices were invented, I think, in the 1800s. So in the 1800s, the term matrix first was invented, and they're used to do all kinds of things in engineering, science, and mathematics, business, finance, lots of applications. So let's get used to this thing called a matrix. It's a box, rows and columns of numbers. So the first thing is the dimension of a matrix. Whenever we speak of the dimension of a matrix, they decided, it was just randomly decided, to go down first and then across. They could have done it the other way. There's no real important logical reason. They just did it this way. Just like we drive on the right side of the road in North America and they drive on the left side in Europe. It's just random choice. They decided to go down first. So how many down? 1, 2, 3, 4, 5, 6 down, and 1, 2 across, as the answers say there. So that the dimensions of the matrix are, it's a 6 by 2. It's a 6 by 2 matrix. So we go down first, then across. Number 2, so now that we have this new thing, once they invented this new thing called matrices and gave them that name in the 1800s, they had to make up the rules for matrices. How do you add matrices? How do you subtract matrices? How do you multiply matrices? And how do you divide matrices? That's basically what we're going to look at in this section, 7.5, and the next section, 7.7, is also on matrices, and there's some applications there. We're going to learn the rules about adding, subtracting, multiplying in this section, and then dividing in the next section. So they made up this new thing called matrices. How do you add two matrices? Well, I think it's pretty natural. I think they did what any of us would have done. They just said add entry by entry. So upper left, 1 plus 4 is 5. Upper right, 3 minus 5 is -2. Now let's shift, lower left, -1 plus 0 is -1, and lower right, 3 minus 2 is +1. There we go. That's how we add matrices. Just add them entry by entry. I think that's exactly what any of us would have come up with. Here's an interesting side point. When they decided, let me ask you, what did they decide about adding matrices that are different sizes? Like, how about if we wanted to add those two matrices? How do we add, so we understand how to add two matrices that are the same size. You just add entry by entry. But how do you add two different size matrices? How do you add two different size matrices? Well, I'll tell you what they came up with. Maybe they could have come up with some amazing thing where they expanded both the matrices or whatever. But instead, they just said, don't do that. Really, that's it. You only add or subtract. Matrices of the same size. That's it. They said don't add matrices or subtract them if they're different sizes. Basically, all of math is made up, like matrices, boxes with numbers in them are made up to help us deal with things in the real world, right? Math is made up. Math is not real. It's just a tool to help us do things in the real world. And so we'll see in the end of section 7.7, we'll see some real life applications of matrices where they're useful, and really there's tons, like I said, in physics, chemistry, engineering, biology, on and on the list goes. Matrices are used a lot to help us do real life things. Specifically, they never saw a real life need for adding matrices of different sizes. So they just simply said, don't do that. We don't need that. We only need to add matrices of the same size. Now, that will not be the case when we get to multiplying. We actually will multiply matrices of different sizes. And in fact, sometimes you can't multiply matrices that are the same size. Sometimes you can. It depends. It's going to be very interesting when we get to multiplying. The rules for multiplying matrices are pretty wild. But for adding and subtracting, adding or subtracting matrices of different sizes, they simply said don't do that. Only add, subtract matrices of the same size, because that's all that's useful in the real world. Let's try number 3 here. Now we're going to take a number like 5 times a matrix. So this is matrix A, right? A equals this matrix. And so we want to take 5 times matrix A. And that's 5 times, let me write matrix A here. So how do you multiply a number times a matrix? They had to make up rules for that. And what would you do if it was up to you to make up the rules for how we multiply a number times a matrix? Well, I bet you would do what I would do and what pretty much anybody would do, and it's exactly what they did. You just multiply all of them, don't you? You just distribute to all of them. That's exactly the rule. So minus 25, minus 10, minus 5, minus 10. There we go. So that's all you do. As you can see the answer over here. So whenever you multiply a number by a matrix, just multiply all the numbers inside the matrix. Number 4, now want to kind of combine these things. We want to multiply a number times matrix C, 3 times matrix C, add to that 2 times matrix D. So how are we going to do that? Well, I think you know. So I'm just going to take 3 right here times matrix C, so 3 times this number, 3 times 5, 15, plus, and then 2 times this matrix, minus 18. Here, I'll come over here and write down the answers. What is that? That's going to be minus 3. Well, actually, we're going to see them right here, can't we? Minus 3, there we go. Next, we're going to take 3. You can go any order you want, doesn't matter. 3 times minus 9, minus 27. 2 times minus 5, minus 10, that's minus 37. Next row, 3 times that's minus 15. 2 times 6 plus 12, that's minus 3. And 3 times minus 3 is minus 9. And 2 plus 2 times 8, 2 times 8 is 16. 16 minus 9 is 7. And bottom row, 3 times minus 7, minus 21. 2 times minus 7, minus 14. It's minus 35. 3 times minus 1 is minus 3. Plus 2 times 2, 4, that's 1. There we go. So just multiplying a number times a matrix added to another number times another matrix. So it's real natural. It's just what you think. Everything's pretty normal for matrices until you get to multiplying. So adding, subtracting, multiplying numbers by a matrix, it's all real regular until we get to multiplying 2 matrices together. That's when things will get wild. All right, number 5, subtracting 2 matrices, real natural and easy. Notice they're the same size, aren't they? You can remember you can only add or subtract same size matrices. So minus 3, because that's all that's useful in the real world, minus 4. So minus 3 minus 4, that adds the 4, positive 1. And then 2 minus 0. That's 2. And 8 minus 7. That adds the 7, 15. And 8 again, minus 6. That adds 6, 14. 6 minus 6, 0. And a minus 1 minus 7 minus 8. All right, 1 minus 8, or negative 1 minus 8, that'll become plus 8, that's 7. And 2 minus 2, 2 minus 2, that'd be add 2, be 4. There we go, real nice and easy, just subtracting two matrices entry by entry. Okay, number 6. Now here's where things are going to get interesting. We're multiplying A times B, multiplying this matrix by that matrix. Notice they're different sizes, aren't they? So the first question is, right here, is this possible or is it not possible? That's what that option will let you choose. Is it possible or not possible? Well, it turns out it's possible. You can tell by the answer down here. But why is it possible? They're different sizes. You couldn't add them or subtract them, right? When you add and subtract matrices, they've got to be the same size. But it turns out it's possible to multiply them. Why? Well, let me go to a room, fresh screen where we get some room here. Okay, so here we go. Now, how do you know if it's even possible, first off? Well, it's all about the sizes. What are the dimensions? What are the what's the size or the dimensions of this matrix? Remember, you go down first, then across. 2 by 2. This is a 2 by 2 matrix. What's the size of the second matrix? Remember, again, you go down first, then across. It's down 2 across 1. This is a 2 by 1. That's important that we don't say it's a 1 by 2. That would mess us up. I'll show you why right now. So you got to go down first. Remember, it's always down first, then across. That's just by common agreement, like driving on the right side of the road in North America. Just not a logical reason, it's just common agreement. Okay, so you got to get those right, though. You can't mess that up. Why? Because now it's possible if these two numbers match. It's possible when the two inside numbers are the same or equal. These two inside numbers have to be equal. You can't do it. You cannot multiply two matrices unless the two inside size numbers, the dimensions, are equal, are the same. So if they don't match, you can't do it. So if we tried to do a 2 by 3 matrix and a 2 by 1 matrix, no way. Or even a 2 by 3 with a 2 by 3. Notice those are the same size, but if you tried to multiply those, the two inside numbers, not the same. So you could not multiply two matrices that are both 2 by 3, both the same size. You would not be allowed to multiply them. You could add them or subtract them, right? You can only add and subtract matrices that are the same size, but you could not multiply them because their inside numbers don't match. Whereas these two matrices, they're not the same size, but we can't, so we could not add them or subtract them, but we can multiply them, which is what we're trying to do here, times them, right? Trying to times them. We can multiply them. Why? Because their inside numbers match. That's when it's possible, when the two inside numbers are the same. Okay, now here's the other thing. The size of, not the size, but the size of the answer matrix is the two outside numbers, meaning this number and this number. So in other words, 2 by 1. The answer matrix will be a 2 by 1. So those dimensions are very important. First off, the two inside numbers have to be the same for you to even be allowed to do it. And then to multiply them, and then if you are allowed to do it, the two outside numbers tell you the size of the answer matrix. So we know the answer to multiplying these two matrices, this 2 by 2 and this 2 by 1, the answer matrix is going to be a 2 by 1 answer matrix, which means, remember, you always go down first. So it means the answer matrix will be, so I'm making that probably too big. 2 down and only 1 across. That's the answer. That's what it equals, the answer matrix over there. Okay, so we know the answer is going to be a 2 by 1. It's good to set that up and have that ready to go. Now, how do you actually find? We know the size of the answer, but how do we actually find the answer now? Well, here's what you do. You take your left hand. Let me kind of get rid of a lot of this stuff here. Make this have some more space. Okay. You take your left hand has to go across. So the left matrix you go across. The right matrix you go down. You multiply and jump. And then multiply and jump. And you add them up as you go. Here's what I mean. You take -3 times -1. You write it here. -3 times -1 plus. And then you're moving across. See that arrow? Means then you jump to the next one. And see this arrow? It's going down. Then you jump down to the next one. This one. And you multiply this guy with this guy. Do you see what happened? So we started by multiplying this guy with this guy. Right? We start at the left and we start at the top. We multiply -3 times -1 and then we jump. We jump to the right here and we jump down there. The matrix on the left, we're always going to the right. The matrix on the right, we're always going down. So now it's 2 times -3. 2 times -3. And so I'll figure that out right now. That's going to be what? +3 minus 6, it's -3. Okay, now let's figure out the bottom. It's going to be the same thing. Go down here in the bottom now. We're going to use the bottom row. Let me write this again. Okay, and so now we're going to be moving across again, and in this one, down again. Same kind of thing. We're just going across the bottom, and we're redoing the -1 and -3 a second time now with the bottom row. Now with these guys, we're already done with the top row. That gave us the top row answer. So now start -1 times -1. -1 times -1 plus. And then you jump. You jump to the right and you jump down. You're always going to the right and down. And now we're going to go 2 times -3. 2 times -3. What is that? That's going to be +1 minus 6 minus 5. We're done. There's the answer matrix. Notice it is a 2 by 1 matrix, right? It's 2 down, 1 across, just like we said right there. That's the answer to multiplying those two matrices. So the trick is, let me recap real quick. You got to write out the sizes first. The two inside numbers have to be the same. That gives you the green light, go. You can multiply these matrices. And then set up the size of the answer matrix by looking at the two outside numbers, 2 by 1. So we set up a 2 down, 1 across answer matrix. And then to figure it out, we come over here and we start on the top row, go across, and over here go down. And you just multiply and then jump and jump. And then you do the bottom and you multiply and you jump and you jump. And you write down your answers, add them up, and there we go. -3, -5. So that's the answer on that one. Let's try number 7. Number 7 is similar. They're giving us matrix A, which is -3, 2, -2, -2, like that. And they're asking us to find A squared. Find A squared. So we know what A squared means. It means A times A, right? So matrix A squared means matrix A times matrix A. Okay, so matrix A, minus 3, 2, minus 2, minus 2, multiplied by minus 3, 2, minus 2, minus 2. In fact, actually, you know what? I need to bring that down. I'm not going to have room if I do it like that. Let's bring it down here. So it's going to be matrix A. Multiplied by matrix A. Okay, let's crank it out. So first off, is it doable? Let's check the sizes and all that. This is a 2 by 2, and this is a 2 by 2. So the inside numbers are the same. So that means you can do it. And the answer, whoops, getting scribbly there. The answer size is the two outside numbers is also 2 by 2. So yeah, it's doable, and the answer will be a 2 by 2 matrix as well. So let's draw it. So it's going to be, got to leave kind of big blanks because we're going to add up a bunch of numbers here. Okay, let's do it. So you know how it works. On the left one, we start going left. On the right one, we start going down. Now notice I'm starting on the upper row, left column. Upper left. So that means it'll go here. What I'm doing will go in the upper left. So here we go. Minus 3 times minus 3. Let me write a little bit better there. Plus. And then you jump right and jump down. Remember, you're always moving to the right and down. So 2 times minus 2. So that we can figure that out right now, I guess. What number is that? So it's 9 minus 4, that's 5. Okay, we got the upper left-hand corner. Now, let's erase this. Oops. Gonna have to just rewrite stuff, I think. It's just gonna get too messy. So let's do that. Let me just rewrite it. Okay, so now we want to do the upper right. Doesn't matter, you can do these in any order you want. So for that I need to do upper again. I'm going to redo the upper. I'll get to the lower in a minute. Doing the upper, but right now, we already did left. I'm done with the left. See how I'm doing upper right to get me the upper right answer. So minus 3 times 2. Plus, and then you jump. You jump to the right, you jump down. This is a weird setup they came up with for multiply matrices, isn't it? 2 times minus 2. So what's that? That's minus 6, minus 4, so that would be minus 10. All right, so we got that one. Let me erase that. Get rid of this. Almost have to redo this every time. So it's, there we go. Okay, now we're going to go, right here, we want this lower left. So you're going to do lower and left. I'm going to redo the left now. Lower left. So minus 2 times minus 3. Plus. Then you jump to the right and down. Minus 2 times minus 2. So what's that? That's going to be 6 plus 4, 10. 10 there. All right, one more to go. Let's clean this up. Okay, so now we're going to go, we want the lower right. So lower right. So, right, the lower row, right column. So minus 2 times 2 plus. Then you jump to the right and you jump down. Always to the right and down. It's always how we jump. Minus 2 times minus 2. What is that? Minus 4 plus 4. 0. And there's our answer. The answer is a 2 by 2 answer matrix. By the way, notice it's not so simple, because you might have thought, well, a squared, I know how to do that. Just square that number, square that number, square that, square. And that's not true, is it? This is 5, not 9. That's not right. So can't do that. Careful. A squared just means a times a, and you just have to write matrix A times matrix A, and then do the long, painful rules for multiplying matrices. And here's the answer from multiplying those two matrices. To number 8 we go. So number 8 is a really, really big one. So let me bring it in up here. It's going to be minus 1, minus 7, minus 2. Here, let me do this better job on this. Minus 1, minus 7, minus 2, and minus 5. And then 10, 7, 6, 9. Okay, here we go. So we're multiplying these two matrices. So the first question is, can we do it? Are we allowed to do it? What's the size of this matrix? Well, remember, you go down first, because it doesn't matter. They're both 4. 4 by 4. The size on this one matters. Remember, you go down first, so it's 4 by 2, isn't it? 4 by 2. Okay, so can we multiply them? Yes, the inside numbers are the same. So then it's okay to multiply. So the answer, what's going to be the size of the answer matrix? Well, remember, that's determined by the two outside numbers, 4 by 2. The answer matrix is going to be a 4 by 2. 4 by 2 answer matrix. The two outside numbers from the dimensions of the sizes of the two matrices tell you that. 4 by 2. Okay. Let's go to it. So here's going to be the answer matrix. So it's going to be 4 by 2. I'm just going to make it really big here. So 4 down, 2 across. So, and here, really, really big, like that. Oh wait, no, 4 down. Getting confused. All right. So 4 down, 2 across. So there we go. So 4 down, right? It's 4 down, it's 2 across, isn't it? 4 by 2, answer matrix. By the way, this is a great moment for me to stop and say, it's easier, I should say it's way easier on the TI-84 calculator or some program online like Desmos. Now, if you go to the homework assignment, you can click on the video. I think the video on the homework assignment shows how to use the TI-84 calculator. I'm not going to do it here. The gentleman does a great job. He shows the TI-84 calculator on the screen and exactly how you multiply matrices on the TI-84 calculator. It's a snap. It's so much easier than this painful long by hand work. Or you can do it on Desmos. I'm not going to show that either. That's pretty easy. Just go on to the desmos.com website and select matrices, and you'll see it's pretty obvious how to put them in and multiply two matrices. So it'd be way easier to do it that way. Look at the homework assignment and click on the video there for the TI-84 method. Or if you don't have a TI-84, go on to desmos.com and you can do it that way. But we're going to do it here by hand, which is much more painful. All right, so how does it work? Let me get rid of all this. You know the deal here. Let me get rid of these numbers as well. We're going to start with the upper left. So that means upper, and I'm going to go down the left instead of the right. Upper left. So here we go. -1 times -4 plus. And then you move to the right. You always move over and you move down. So it's 10 times -6 plus. Move over and down. -3 times -9 plus. Over and down. 8 times -8. I was sure I had enough room, but even that wasn't quite enough. Let me expand it just a little bit. All right, there we go. Okay, so there's the upper left. Now we can just figure out what that number is. What is that? 4 plus -60 plus 27 minus 64. Use your calculator. You'll find, in fact, why don't I write the answer up here? You'll find that the answer to all that is -93. Okay, let's keep going. Next one. So now I'm trying to do the upper right. So I'm going to go upper, and now I'm going to go down the right. So I'm redoing the upper. I'm still on the top row here, but I'm doing the right now, the upper right. So -1 times -5 plus. Go to the right. Go down, always. 10 times 2. Plus, go to the right, go down, always. -3 times -10. Go to the right, go down, 8 times 1. All right, so that's 5 plus 20 plus 30, two negatives there, plus 8, if you can read all my little scribbles. I'm running out of room there. 63. Upper right. Okay, let's keep going. Now, I'm going to come over here. I'm going to do the second row. So I'm going to go second row on the left. So I'm going to go down the left. So here we go. -7 times -4. Plus, move to the right, move down, always. 7 times -6, plus, move to the right, move down, 1 times -9, move to the right, move down, -10 times -8. All right, what is that? That's 28, positive 28, minus 42, minus 9, plus 80. If you work all that out, you'll get 57 on your calculator. Now we're going to go, where are we at? How about the middle or the second row on the right side? So we're still using the second row, but now I'm going down the right side. So -7 times -5 plus, go to the right, go down always. 7 times 2. Go to the right, go down always. times minus 10. Go to the right, go down always. Plus minus 10 times 1. So what does all that add up to be? What's that? 35 plus 14 plus minus 10 plus minus 10. Is that like 20? Yeah, 29 on the calculator. Okay. Let's see. I'm kind of running out of different colors here. All right. So I'm going to go down to the... So now I'm down on the third row. Start over on the left. Third row on the left. So minus 2 times minus 4. Plus. Jump to the right, jump down. 6 times minus 6. Jump to the right, jump down. 3 times minus 9. Jump to the right, jump down. 0 times minus 8. What's that? 8 minus 36 minus 27 plus 0 comes out negative 55 on your calculator. Okay, now I'm going to go again, third row again, got to finish the third row, but now the right side. So I'm going to go down the right side over here on the third row. So negative 2 times negative 5. Jump to the right, jump down always. Plus 6 times 2. Oops, let me try that again. Jump to the right, jump down. 3 times negative 10. Jump to the right, jump down. 0 times 1. So what do we get? 10 plus 12 minus 30 plus 0. So minus 8. All right, we're getting close. One more row, bottom row. So to the bottom row we go. I'm going bottom, and I'm doing the left side of the bottom. So bottom row here, left side. So start here on the left. So negative 5 times negative 4. Plus, jump to the right, jump down always. 9 times minus 6. Jump to the right, jump down. Plus negative 8 times negative 9. Plus, jump to the right, jump down. Negative 4 times negative 8. All right, what's that? Plus 20 minus 54 plus 72 plus 32. That comes out 70. One more final thing, the lower right. So I'm doing the lower and I'm doing the right. Minus 5 times minus 5. Jump to the right, jump down always. Plus 9 times 2. Jump to the right, jump down always. Minus 8 times minus 10. Jump to the right, jump down always. Minus 4 times 1. I'm going to run out of room there. So what's that? 25 plus 18. Minus 8 times minus 10 is plus 80. And minus 4 times 1 is minus 4. Do those on your calculator and you get 119. There we go. Is the whole incredibly difficult thing done. So like I said, way easier on the graphing calculator TI-84. Just go to the homework, click on the video on the homework, and that gentleman will show you how to do it. on the TI-84 right on your screen, super easy. Or you could go online and use desmos.com, use the matrix calculator there. Be way easier than doing this. There we go.